here's integrated 3. It's problem 3-96. It says sketch the graph of each of the following on a different set of axes. So we've got these inequalities that we're supposed to graph. So the first thing you want to do with these is get them in y equals form. So hopefully you can notice that this is going to be a linear graph. So I just kind of, rearranged it so that it's y equals form. And then I'm just going to go ahead and graph the line. So that's the first thing I'm going to do. And this one, I think I can make it pretty small. I have to do separate axes. So I want to try to fit several graphs on the same page if I can. Not on the same set of axes, but so there's x and y. And so if I'm doing y equals 3x minus 3, I look here and this is the y-intercept. And this is at 1, 2, 3. That's -3 right there. Okay. And then this gives me my slope. And the slope tells me to go up. It's like rise over run. I want to go up 3 over 1. Okay, and I can keep continuing. I can go up 3 more over 1 like that. And I can go down, but I just want a pretty little graph. I'm going to be careful with whether I draw a solid line or a dotted line. I see that I have this kind of inequality that's just greater than, so I want to draw the dotted line instead of a solid line. And so I think the reason I'm making this video is that I see people's graphs and it's just like this might be a 5 right here or something, or you're counting by 5s. And I can't tell, like I need some, when you draw a graph, you don't just willy-nilly go, there it is. You have to, there has to be some points on the graph that actually I could go plug them back into the equation and it would make it true. So I'm going to mark, take points off if I see graphs that don't have any points at all on them. So I'm supposed to shade because it says y is greater than 3x plus 3, but where do I shade? Should I shade below or above? Well, greater than means above, and just to make sure, I'm going to check the point 0, 0. So this point 0, 0, if I plug it in, I would get 0 is greater than 3 times 0 minus 3. And I want to find out if that's true or not. Is 0, well 3 minus 0 is just 0. Is 0 greater than -3? Yes. So I'm just going to shade above it, and I just show it with some lines. This pen, if I was using pencil, it'd be a little easier to show the shading, but something like that. Or you could use a highlighter or just scribble above it. Okay, so that's the answer to letter A, and I'll label it. It is y is greater than 3x minus 3. Okay, letter B. Letter B is 3 is greater than y, but I just changed it into y equals form. So basically, I want to graph y equals 3. So maybe I'll do it right here. Here's letter B. I didn't really need to make my graph this big, but I guess I did. So y, so this is going to be y is less than 3. So everywhere on my graph where y is less than 3, so there's 1, 2, 3. It doesn't have the little underline underneath my inequality, so I'm going to be careful to just make it a dotted line or a dashed line. And y is less than 3 down here. If I wanted to check, I could plug in 0, and so it's kind of, this one's kind of a weird one. And I'm just going to do some shading. So that's the answer to letter B. And then letter C is 3x minus 2y is less than or equal to 6. On that one, I could put it in y equals form, but since 3 and 2 actually both go into 6, I'm going to not put it in y equals form. Normally, it would help to put it in y equals form, but I think it's very easy to graph without y equals form. So I'm going to go ahead and get a graph. Make sure, I don't really want to make it super big. Let me write down what it was. It was 3x minus 2y less than or equal to 6. Less than or equal to 6. So on one like this, I'm going to use what I call the cover-up method. I'm going to get the intercepts. So I can get the x-intercept when y is 0. So when y is 0, I can just cover up the 2y, because negative 2 times 0 is 0. And then I end up with 3x equals 6. So I know x is 2. So my x-intercept is 2. And then if I cover this up, because we know the y-intercept happens when x is 0. When x is 0, the 3 will go away, and I'll have negative 2y equals 6. Well, if I divide both sides by negative 2, I would have y is equal to negative 3. 1, 2, 3. I'm not really labeling these, but this is negative 3. You don't have to label them if you just count by ones instead of counting by fives. Okay, so, if you count by fives, you have to label them. But I'm counting by ones. This is 2, and this is negative 3. And then I'm going to make a solid line because of this, it's less than or equal to. And then I'm going to test a point because I don't know if I'm supposed to shade above the line or below the line. So I'm going to just plug in 0, 0 because that's easy to plug in. So if I plugged in a 0 here, I would get 0, and a 0 here, I'd get 0. So I'd have 0 is less than or equal to 6. Is that true or not? Is 0 less than or equal to 6? Yes, it is. So I'm going to shade the part where the 0 is. Okay, and then letter D. Letter D is x squared minus y less than or equal to 9. So I wanted to rearrange it to get it like in standard form or maybe graphing form. It turned out I didn't really need graphing form. Well, I guess it is in graphing form. I just rearranged it. And so I'm going to graph y equals x squared minus 9, and then I'm going to test a point. Now, I know x squared minus 9 is going to be like, if that's negative 9 right there, it's just going to look like that. I don't know if I want it to be super perfect, but I definitely need that point right there. So I'll make sure that my graph goes that low. So this is y is greater than or equal to x squared minus 9. So I'm going to get an intercept at negative 9 on the y-axis. 2, 3, 4, 5, 6, 7, 8, 9. And then I could just plug in a couple points to get these ones. Oh, or I could factor. I could factor this quadratic because I know that this is x plus 3 and x minus 3. That's how I can factor this, and I know that if I set those equal to 0, I get -3 and +3, so. And then I'm just going to try to make my graph not look too weird. But at least now I have some points on my graph, okay? I didn't show any numbers because I'm counting by ones. Okay, this is 3. It's very obvious that this is 3 and this is -3. If you count by 2s or 5s, you have to write all those. And then I want to shade it somewhere. And this says y is greater than. So I think I'm going to end up shading on the inside because that's where the big y values are going to be. But I can check by plugging in the 0.00. So if I plug in a 0 here, is this a true statement? Is 0 greater than -9? Yes. So I am going to shade inside here. Okay, and then did we do everything that it asked? Yes.